Alright, welcome everyone. Now we know that we can connect carbons and also we can put some other atoms. But also we know how to draw a ring structure, and we know how to put the big groups on the equatorial. Then we know the structure around the double bond here. They're flat, and nitrogen has a pair of electrons, and this one has sp3 hybridization, and it is actually tetrahedral. And there you have two more electron pairs to be neutral, and they are having tetrahedral arrangements, but overall shape is bent. And also we know this is chiral center, although it's not shown wedged or dashed. So if it is dashed, you know, this carbon is CH3, we know that, and that is a CH, we know, and that hydrogen actually is going away, and they're almost overlapping from this perspective of the camera. Then we know there is hydrogen on the axial, hydrogen axial, equatorial hydrogen, and so on. And we also know this and this is eclipsed, and you can draw a Newman projection from this perspective or the other perspective to prove that they are all eclipsed and that's not stable. So this single bond is bound to be rotated to be more stable to lower potential energy, and so on. I may say this many times because it's very important. If you do chemistry without having clear understanding and visualization of molecules, then doing chemistry will be very tough. You will almost feel like you are doing some philosophy. Without understanding the essential being, which is molecule, how would you possibly understand chemistry? So the more time you spend, you get better, clear understanding of the overall structure, and you can imagine it better, and you can actually visualize molecule without having model or drawing in front of you. That allows you to understand the behavior of chemicals better. In this video, we'll talk about naming molecules. We've studied significant amount about molecule, so now we need to know how to name them, the whole molecule or sometimes parts of molecule, as well as their geometry, their shape, and special conformation and configurations, and the relationship of each isomers and things like that. And you have to include all of those in namings. But we'll just briefly do naming for now, for all the just general common functional groups. First, in order to name molecule, you have to find the major part. So main chain or mother chain. That's usually the part of the molecule that has a consecutive connection of carbon, and that should be the biggest and longest chain of carbon. Then you find things that are attached with a fewer number of carbons, so we call it side chain or substituents. Then we give number to indicate the location of each attachment. So you give numbers. So numbering of the main chain is part of the naming. Then you have to notice what type of functional groups you may have. So functional groups. And that should be also part of the name. Then obviously the isomerism, like if you have a chiral center, R or S. If you have a cis-trans isomerization, you also indicate trans or cis, etc. Like human name has family name and first name, you can roughly say the naming for the compound consists of information about side chain, then information about main chain, then you give information about functional group. And all other isomerization and configuration and such information goes in front with the numbers. So let's begin with a few representative information. First, for the main chain and the side chain, you need to know this root name that comes by number of carbons. So if you have one carbon, the root name is meth. If you have 2 carbons, F. 3 prop. 4 but. 5 pent. 6 hex. 7 hept. 8 oct. 9 non. 10 dec, etc. So if you practice, if the main chain of a compound is this, then you can count 1, 2, 3, 4, 5, 6 carbon, so the root name would be hex. And if the main chain has one side chain, then that side chain has a root name because it has 1 carbon, meth. Let's practice. So let's find the main chain. You need to find longest chain for the main chain, longest consecutive carbon chain. So you have 1, 2, 3, 4, 5, 6. Then 7, 8, 9 or 9, either way. You wouldn't go from here 1, 2, 3, 4 or 1, 2, 3, 4, 5, 6, 7, 8, right? So 9 carbon chain is the main chain, and that would be the root name non. Then you have a 2 side chain with a 1 carbon, so each has root name meth. Alright, so first thing we did to name compound was find the longest chain as well as side chain. You need to practice. Sometimes it's not as easy to see. The second thing we will do is finding type of bonds and the functional group that you have in order to give number. And ending name. So if you look at this molecule, for example, you have only a single bond. So when there is only a single bond, you give the functional group name A-N-E. For the double bond, you give E-N-E because it means it's alkene. And A-N-E for alkene. So the name comes from alkene and alkene. And triple bond, you give Y-N-E because it is alkyne. So for the main chain over here, you had 9 carbons with only a single bond, so we call it non, then A-N-E, nonane. And this side chain, you don't end with the A-N-E, you put Y-L. So we call methyl. If the side chain had 2 carbons, then we would call it ethyl, propyl, butyl for the 3 and the 4 carbon side chain. Then we give number. So in order to give number, you have to find which end of the main chain you start numbering, and the rule is always you give lowest possible number for first functional group. Then you give a priority for the side chains. Here you don't have particular functional group, so you give a priority to the methyl groups. But you have 2 methyl groups. Which one should get the lower number? If you start from this end, it's gonna be 1 and 2. This one gets 2, and 3, 4, 5, 6, 7. This gets 7. The other way, 1, 2, 3. This one gets lower number 3 instead of 7. However, 4, 5, 6, 7, 8 end up getting 8. So do you prefer 2 and the 7 or 3 and the 8? The rule is you give lower number. So number 2 is lower number than the 3. So we keep the first numbering system. So you have 2 methyl and 7 methyl and the nonane. Then you put them together in this order. But one more rules when you put them together. You put the multiple same side chains using the prefix like di, tri. So what we do is we put these 2 first with the prefix di. but you put number first, like I said here, number, and the isomerism information here. So number and the isomer information here. So you put 3, 7 with a comma, then hyphen between number and the letter, then dimethyl. So we did side chain, then you put the main chain with a functional group, which we don't have in this case, so non-ane. Okay, why don't we try this example? You can pause and try yourself. Alright, so where is your longest chain? Well, in this case, it's fairly easy. You can start from here or there, and you found this to be your longest chain, and you have 2 side chains. The longest chain has 1, 2, 3, 4, 5, 6, 7, 8, so it is oct. With no double triple, so ANE. Then you have 2 side chains. This one has a 1 carbon in it, so meth. 2 carbons, F, and because it's a side chain, ethyl, methyl. Then you have to number. So here you have a dilemma. Whichever end you start, you get same number for the 2 side chains. You have 1, 2, 3 for the ethyl, 4, 5, 6 for the methyl, or 1, 2, 3 for the methyl and 6 for the ethyl. Which one do you take? And there you have to add one more rules to this. When you give lowest possible number for the first functional group, then side chain, but when you have more than one side chain with the same number, then you give alphabetical order, which means lower alphabet group gets lower number. So here you have E versus M, and E should get the lower number, so you should try give 3 to the ethyl and 6 for the methyl. Then you put them together and you give 3 ethyl. It goes not by the number, but it goes by the alphabet. You put the E first, then letter separated by number by hyphen, then 6 methyl octane. You can think of examples like this, very similar. I'm just making it up. So if you have to number this one, you get the point. Same octane. You have a methyl, getting number 3 either way. So it doesn't matter because they're same methyl. Then what would you do? Well, you guessed it. The next group gets lowest possible number because the first one has tie. So to give this one lowest possible, you give this one 3, 4, so this gets 6. So the numbering is tricky. but the rule is always give lowest possible number for functional group, then the side chain among them, the lower alphabetical order first. Okay, why don't you try this one? I'm not going to name fully to save time, but I'm just going to tell you the main point. You would think you want to give lowest number for functional group, and you see the chlorine. The question is chlorine side chain or functional group? And according to the IUPAC, the halogens are not considered as functional group, although in chemical reaction it acts as a functional group. So you consider that as alkyl group, side chain. So as you see, you have 1, 2, or 1, 2, 3. So you go from here, 1, 2. Even though the third group could have lower number if you go from here, it doesn't matter. You want to give lowest possible number for the first side chain. So 2, 3, 4, 5, and 6. When you put the side chain names together, you go by the alphabetical order. But you have one more issue here. How do you name this thing? So this Y-shape side chain with a 3 carbon is propyl. But because of the shape, the common name is iso. So you can call it isopropyl. And that's acceptable, but it is common name. There's a way of naming isopropyl according to the IUPAC system, which is same as naming main chain. So if you consider this side chain, the carbon of the side chain that's bound to the main chain is always the beginning. It's always number 1. And starting from there, you find the longest chain of the side chain. So either way, you go here, there's a 1. There's a 1, so it doesn't matter. So you pick this as a main chain of the side chain, there are 2. So you give ethyl, because side chain. The ethyl has 1 side of the side chain, like a little tweak. And that's only 1 carbon. That's on the number 1. So you can ignore 1, or you can write it out. Say 1 methyl ethyl. That's IUPAC way of naming isopropyl. And if the side chain is like this on the main chain, you can call that as 1, 2, 3, 4, 5. So pentyl, but that's different from 1, 2, 3, 4, 5. This pentyl as a side chain. So we give N for the normal chain, N pentyl as a side chain name. This one that has the secondary carbon connected to the main chain, we give sec, secondary pentyl. Or you can have this kind of 1, 2, 3, 4 carbon side chain. Again, the common name is butyl, but because it has tertiary carbon, meaning the carbon connected to the main chain has 3 carbons, so 3 degree tertiary T-butyl. So when you put these side chains in the name, you don't you consider iso I as an alphabet in the ordering, but you don't consider tertiary or secondary or normal in the alphabetical consideration. You consider P, B, P. Also, in the name, when you have to order dimethyl and ethyl and say propyl, you order them in the name by ignoring di, tri, but use M, E, and the P. So regardless of the number, say you have a 6 and 5 and 2 for that, regardless of number, this goes first, then M, so 2 dimethyl, then 5 propyl, then there goes the name for the main chain. So yes, we are talking about the order of the side chains when you put the names together. So the side chain that has a lower alphabet goes first. When you give number, you give lowest possible number for the side chain if there's no functional group, and we are saying chlorine is not functional group. And there are some complicated structures of side chain, such as iso, secondary, T-butyl, normal pentyl, such as a long chain as a side chain. So there are some complications. So if you try to name T-butyl according to the IUPAC, how would you name it? Like I said, the carbon of the side chain connected to the main is always number 1, and starting from there you are looking for the longest chain, and there are 2. Then you have a 2-methyl group on the number 1, so T-butyl would be ethyl, but that ethyl has 2 methyl groups, so dimethyl, and you have to say 1 and 1, but because number 1 always you can omit, so you don't have to write. So dimethyl ethyl for the T-butyl. I'll show you one example later on how do you actually put all together. Now let's practice the case when you have a functional groups, because if the molecule has functional group in it, some rules bent. Even when you look for the longest chain, some rule change, and giving numbers also you have to make some changes, and also you have some problems in ordering multiple functional groups name at the end of the whole name. Let's try this. You can pause. There are 3 examples. Alright, so this is straightforward. The longest chain is 1, 2, 3, 4, 5, 6, and 7 carbon chain. There's no side chain. Then you notice there are two sort of functional groups. So this is, like I said earlier, double bond. So the name for the functional group is ene, and that is YNE. And usually triple bond gets lower possible number. So this is even more obvious because that's a determinal. So you give number 1, not 1 and 2, just 1. Then 2, 3, 4, 5, not 5 and 6. Then the main chain is 2, 4, 6, 7. So you have hep. Then when you put together, there's no side chain, anything else, but you have double bond and the triple bond, and double bond start with a E, and triple bond start with a Y. So the 5 ene and the 1 ine, when you put together, regardless of the number, you put the functional groups alphabetical order, so ene first. But when you put another functional group, you omit the ending E. This could have gone too if there's another higher prioritized functional group. So 5 ene and 1 ine. You put E because that's the end. And you can certainly put the double bond isomerism. In this case, there is trans. So trans hept 5 ene 1 ine is the name. Here you find the longest chain 1, 2, 3, 4, 5, 6, and 7, and you have 1, 2 for the oxygen, 3, 4, 5 for the double bond, or you can give 1, 2 for the double bond, 3, 4, 5, 6 for the alcohol. Although the lowest number is the same, we choose this one. It's because oxygen has priority over the double bond. So how do you decide that? So please remember this. The priority goes from the bottom to the top. Excuse me, so bottom is the highest priority, so actually lowest priority and the highest priority. So the most oxidized one, carboxylic acid, when you give the functional group name, it is oic acid. For the aldehyde, Al, like aldehyde, right? So al. And for the ketone ends ONE, so ONE. Alcohol, so OL. Amine, something amine. So according to this priority table, you can see the alcohol has a higher priority than these unsaturated pi bonds. So again, among the functional group, you give lower number for the higher priority. Remember, for the side chain, you give lower number possible. But if there's a tie, then you give lower alphabet one, lower number. For the functional group, there's a priority. So because of that, the numbering change, because functional group is more important than side chain. So when you have number 2 here, and even when you have a side chain here, obviously OH takes the priority, but even when you have another functional group double bond, OH is a higher priority functional group, so it gets lower number. So the longest chain is obviously 2, 4, 6, 7, so same hept. But since there is a double bond, you put EN, and that's at number 5 and 6, but we only put number 5. Then you have number 2, OL. We put OL after EN because OL starts with the O and EN start with the E, so alphabetical order. And we gave the location for the functional group. Then obviously you have to say trans hept 5 in to all. Let's look at the next one. Which one's the longest chain? You want to say 2, 4, 6, 7, but it's not, because you have to include OH in the main chain if it's possible. So although 1, 2, 3, 4, 5, 6 is the shorter, you choose that as the main chain. So the rule change. When you choose longest chain, you choose the longest chain for functional group. Because after all, the chemicals are used as reactant, so what makes them reacting is functional group, and what gives the compound the main property is the functional group. So you choose this and you give a numbering priority for the functional group. So 1, 2, 3, 4, 5, 6. There are 6 carbons, so hex, no double bond, triple bond, hexane, but no E because you have to put OH functional group name, which is all. When all has number 1, well, you can omit the 1, so you can just simply say hexan OL or hexan 1 OL. But that has one side chain, 2 carbon, so ethyl YL for the side chain, and that's on the number 2, and there's only one side chain, so you put 2 ethyl hexanol. That's the name.